Activation energy. Activation energy. This is today's lesson. Let us see the matter in detail. Activation energy, which is related to chemical reaction. Let us consider a chemical reaction of compound AB and another compound C. When compound AB reacts with compound C, then suppose compound A and compound BC are formed. Actually, this reaction completes in two steps in this way. Compound AB plus C. First of all, these compounds absorb energy. Suppose this is 7 kilojoule energy. Compounds AB and C initially absorb 7 kilojoule heat, 7 kilojoule energy. Then these compounds changes to this complex structure. Bond between A and B breaks. At the same time, bond between B and C forms. Breaking of AB bond and formation of BC bond go on at a time. That is, at the same time, bond between A and B breaks and bond between B and C forms. It happens at a time, absorbing 7 kilojoule energy, for example. Then this complex structure changes to final products with the release of some amount of energy. Suppose this is 5 kilojoule energy. That is to say, in the first step, compounds absorb some amount of energy to form complex structure, and in the second step, this complex structure releases some amount of energy to form final products. Here, this complex structure is known as transition state. This is also known as activated complex. Activated complex, transition state or activated complex. Here we see that what is the difference? Delta H, it means heat of reaction. That is, it absorbs 7 kilojoule heat and releases 5 kilojoule heat. That is, the reaction absorbs ultimately 2 kilojoule heat. As the reaction absorbs some amount of heat, considering this point, this reaction is called endothermic reaction. But suppose this reaction absorbs 7 kilojoule heat and it releases suppose 9 kilojoule heat with the formation of the products. Then here heat up reaction absorbs 7 kilojoule heat, but it releases suppose 9 kilojoule heat. Then ultimately the reaction releases 2 kilojoule heat. Considering this point, in this case the reaction will be called exothermic reaction. That is, when a reaction absorbs some amount of heat with the formation of the products, then this reaction is called endothermic reaction, and the amount of heat absorbed is denoted by delta H. And when a reaction releases some amount of heat with the formation of the products, then this reaction is termed exothermic reaction, and in this case value of delta H will be negative. Now let us go to the main point, activation energy. Actually, this amount of energy for this reaction is called activation energy. Activation energy is denoted by EA. Now let us define what is activation energy. The amount of energy which is required for reactants to occur a chemical reaction. The amount of energy which is required to take reactants to form activated complex. The amount of energy which is required to take reactant molecules to the transition state. That amount of energy is called activation energy. Now let us see activation energy graphically. Y-axis, x-axis, 0, 0. Along y-axis, energy, and along x-axis, progress of reaction. Here reactants are A, B and C. All compounds have internal energy, so it will be started from here because all compounds have internal energy. It will not be started from 0, 0. It will be started from here. A, B and C. Then the compounds absorb some amount of energy, and here this point is actually point of transition state, breaking of AB bond and forming of BC bond. This is state which is called transition state, and the state of compounds is known as activated complex. Now here the compounds absorb energy to be activated complex. Then the activated complex releases energy to form final products A plus BC. Final products. Here, compounds AB and C absorb this amount of energy, which is denoted by EA, activation energy. The amount of energy absorbed by the reactant molecules to be activated complex. That amount of energy is called activation energy, which is denoted by EA. Now, activated complex releases energy to form final products. Here, it releases this amount of energy, which is less than the activation energy. So, some amount of energy, for example, this reaction plus 2 kilojoule, this amount of energy is stored in the products. That is why this reaction is called endothermic reaction. This reaction absorbs 7 kilojoule heat, but it releases 5 kilojoule heat. 2 kilojoule heat is stored in the products. So this is endothermic reaction. But when the reaction activated complex releases more amount of heat to form final products, then here we see that it releases more amount of heat, which is 9 kilojoule. That is, here the reaction absorbs 7 kilojoule heat, but it releases 9 kilojoule heat. It means it releases 2 more kilojoule heat. In this case, this reaction will be called exothermic reaction. That is, we learned here activation energy, endothermic reaction, and exothermic reaction. Now, let us see examples of endothermic and exothermic reactions. Reaction of carbon and oxygen. Here, product is carbon dioxide. Gram atomic mass of carbon 12 gram. Gram molecular mass of oxygen 32 gram. Gram molecular mass of carbon dioxide 44 gram. That is, here when 12 gram carbon reacts with 32 gram oxygen to form 44 gram carbon dioxide. Here, amount of heat released is minus 393.4 kilojoule. This amount of heat is released from the reaction to the surroundings. So, this reaction is a kind of exothermic reaction. And here, heat of reaction is 393.4 kilojoule. Now, let us see endothermic reaction. Calcium carbonate. Gram molecular mass of calcium carbonate is 100 gram when This is heated, symbol of heat. Then calcium carbonate changes to calcium oxide and carbon dioxide. Here, gram molecular mass of lime, calcium oxide, 56 gram and 44 gram for carbon dioxide. Here, this reaction occurs with the absorption of some amount of heat, which is plus 178 kilojoule. That is, this reaction completes with the absorption of this amount of heat. So, this reaction is called endothermic reaction. This is endothermic reaction, and here heat of reaction is 178 kilojoule. That is, this reaction absorbs 178 kilojoule heat from the surroundings, and this reaction releases 393.4 kilojoule heat to the surroundings. Activation energy, endothermic reaction and exothermic reaction. Thank you for watching.